Hello, everyone. Let's wait for a minute. I still do see people joining. Then we are going to start. All right. Hello, everyone, and welcome. Great to have you with us for the December edition of Detection and Intelligence Highlights. I am Ertuğrul, Senior PMM here at VMRay, and I'm joined by my colleague Julian Wolf from our labs team. He's a threat researcher here, and before that, he spent years as a hands-on practitioner analyst in enterprise environments. That's what I know. So he has experience from the front lines. Hi, Julian.
Hi, Arthur. Thanks.
Amazing. So it's the end of the year, obviously, and it's a good moment, I think, to zoom out for a second. So over the course of this year, we have added dozens of new VTIs, new detections, new config extractors, and I think we can safely say hundreds of new YARA rules, all really driven by how fast the threats keep moving and threat landscape changing. And occasionally, we also touched on some product updates on top of detections. And last time, we introduced our new threat intelligence suite, Unique Signal. It's kind of our way of turning malware behavior into actionable intelligence. And going forward, you see more of that campaign level insights, new tactics, and threat actors and patterns emerging across samples. And today, really that ties nicely into one of the spotlight topics, ether hiding. Julian will walk us through how Stealer uses ether hiding and why it is such an effective technique for especially resilient campaigns. And of course, quick housekeeping before we start. The session is being recorded. We share the recording and slides afterwards. And we'll have time for Q&A at the end. So feel free to shoot your questions in the chat. And I think we can get started. So here is the plan for today, pretty usual. We start with the new VMRay threat identifiers, then move on to YARA rule updates and detection highlights. After that, I'm gonna hand it over to Julian for a threat spotlight, as we mentioned, and we wrap up with Q&A at the end. So let's jump in. So the first VTI, this is about actually kind of connecting the dots between two separate VTIs. We had one for direct system calls you see on the screen here. So very good one because direct syscalls are commonly used to bypass hooking-based solutions like EDRs or some sandboxes as well. And in a recent, actually, mass logger sample, but I don't think it's limited to it, but it was seen some of those API calls like could signal process injection. And it's worth flagging as it becomes really a strong signal of evasive behavior. And this VTI makes that kind of the scope of intent more visible to us, to you. And high VTI score you see here, 4 out of 5. And like a bit technical to explain how it works front. So I will drop a couple of links after the session if you want to really read more, and including one of actually our own write-ups on around indirect syscalls also explaining direct syscalls. So feel free to take a look at those resources. So another VTI, is kind of pretty straightforward, as its name suggests. It detects when a dropped file tries to masquerade as a legitimate system utility. So, I mean, obviously the idea might be relying on file names that look familiar to get into kind of allow lists, or at least, to avoid some raised eyebrows. In the samples we observed this in Salat Stealer as well as Masslogger. So the draw files use names like MSI exec or system helper, so things that look harmless at a glance. And the VTI score at 3 out of 5 is definitely something you want to pay attention to. And on our end, we will keep monitoring it for potential false positives. So the last VTI is a phishing focused one, branded captchas. I mean, captchas are already a headache for automated analysis. We know that. Attackers know that, and they keep improving how they use them. And one of the latest tricks we are seeing is overlaying captchas with brand logos, like you see on the screen here. Microsoft, it can be cloud services, file sharing platforms, to make the page, of course, look more legitimate and increase user trust. So with this VTI, we call it meta VTI. We now flag and score that combination. On its own, a captcha isn't malicious, at least not always. So the score is not that high. It's kind of heuristics. So that kind of explains why the score is not that high. We'll talk a bit more about CAPTCHA in a few minutes. There are also new detections on the YARA front, but this is the VTI piece of it. So moving on to the YARA rules, really quick, a quick stop at this front. As you can see on the slide, there is quite a list again this month: loaders, backdoors, stealers, the usual categories. No time really to demonstrate all. Instead, what I want to highlight first is the work around captchas. These are really tough to crack. And on top of VTIs that we just shared around captcha, so we improved auto UI, for example, automated interaction with captchas. The most recent improvement was around Cloudflare captchas, which really we see everywhere in many samples. And more, we also using YARA as another detection layer. One example is the sliding ones, where probably you're familiar, you're dragging a puzzle piece into place. And another big one is the fake captcha. That's another technique. These require really heavy user interaction, like copy-paste commands, click fix type, like fake verification steps. And this was extremely popular throughout 2025. And it's known as really one of the most used initial access techniques, often leading straight to a infostealer payload. It can be a Luma, it can be stealthy or another infostealer. One more thing I want to call out before I hand it over. We also added YARA rules for suspicious VS Code extensions, and that's an interesting area, and I'm actually curious to get Julian's take on that. Julian?
Yeah, thanks,
Dice
Artu.
around that. Thank you.
So yeah, VS Code extensions. I think most people will have read about malicious ones. They've been in the news quite frequently recently, and from a sandbox perspective, these are not so easy to analyze, because we need to have the environment, we need to have a VS Code instance, we need to install the plugin and everything. So this needs to be prepared. And what we're trying to do is here as a first step is to write static detections using YARA rules to identify these VS Code extensions, even if they cannot execute properly in some cases. because there are JavaScript files that or something like that that need a specific environment, to execute, which is always a challenge when running a sandbox to mimic that environment.
Yeah, amazing. I think this was part of a wider supply chain risk, right? The VS Code extensions. Am I right?
Yeah, they've been basically for a while now already, and they pop up quite regularly on the VS Code marketplace. And yeah, there's definitely a need to also detect those.
Yeah, as part of an instant response process, for example, if you want to analyze suspicious VS Code extensions that you're not sure if it is malicious or no, definitely now we have the YARA rules for that, and it can be analyzed statically. Nice. Thank you, Julian, for the insight on that. And as we mentioned in the last session, I'm going to pass it on to you, but going forward, we want to share more intelligence highlights alongside detection updates. So things like really new campaigns, new malware. This section is actually a reflection of that approach that we shared in recent webinars. We are sharing some latest findings from our labs, from Julian, on social platforms. For example, this one was shared on X, but we wanted to expand our reach and get some more knowledge and make this accessible to our audience. And so you will see more of that. That's kind of my summary. And with that, now I'm gonna pass it over to Julian. Julian, please take it away.
Yes, I will share my screen real quick. Thank you. Yeah, so we want to share the shark stealer and the ether hiding technique because I think it's a very interesting technique. It's not new, so this was first reported, I think, in 2023. And used by Clearfake, actually, where they stored malicious JavaScript code on the blockchain. So it's not a new technique, but it's not widely used, and I think it's also not widely known or reported in a lot of cases. So why is it called ether hiding? So basically, what the threat actors then in 2023 did, they used public blockchains and they stored malicious JavaScript code on there, which was then accessed through some kind of API usually. And which makes it very difficult to take down this malicious JavaScript code or the malicious code, or it could also be data stored on the blockchain. So it's difficult to take down. And it's basically usually accessed through a legitimate API service. So there's no like malicious C2 domain or anything, except this legitimate service used to access the data there. And there was a Google report from Google Threat Intelligence a couple of weeks ago, I think it was, that also North Korean state actors are using this technique now still in like very, very, very sophisticated social engineering campaigns with like fake recruiters, fake coding challenges, and then also using multiple blockchains and multiple stages of this ether hiding. And why we want to share this here today is also because we saw this technique in a stealer called Shark Stealer. I've also seen the name Shark Clipper somewhere because of its tendency to access the clipboard and to read and potentially also manipulate the clipboard for cryptocurrency stealing, for secret stealing, or also modifications, for example, to change a wallet address or something like that. And the Shark Stealer is using ether hiding to store actually C2 information. So it's not storing malicious code or anything on the blockchain, but it's storing C2 server information on there. And this is interesting. We developed the config extractor for it, so we can actually extract the necessary information for this C2 communication for the data that's being pulled from there. And I also think it's a very interesting piece of threat intelligence, more or less, because the way the threat actors access the blockchain is very static. It's always the same API, basically. So even if we don't know how it's being stored there, or if it's encrypted, or how it's encrypted. We know how they access it, this blockchain, through one very specific API endpoint. And that alone, I think, is very actionable threat intelligence, because it's probably in a lot of environments not very prone to being a false positive. It's probably not triggering a lot if you try to detect it or potentially even block it. And it's one very stable indicator basically that we've seen for the whole year for this malware family. Yeah, this is cool from that perspective as well. So what I've here is a dynamic analysis report of a shark stealer sample, which we analyzed 2 weeks ago. And yeah, we can see a bit of our VTIs, what behavior we see here. We see the input reading basically from the clipboard data. And we see also that our config extractor extracted a configuration. There's also some C2 communication that we will see here. And then there is the configuration, which we'll go into a bit later. It's also, since it's the final payload in an infection, not a very complex process chain what we see here. So we see the sample starting, and then the sample actually executing CMD exe for persistence. So it's creating a registry key here. And then it achieves the persistence as shark browser, C program data shark browser exe, which after reboot is what this process runs as. So not a very complex chain of processes what this malware executes here. But our main focus for today is, of course, how it achieves the config and how it's pulled from the blockchain. And we have a bunch of things here in the extracted config, and we will go into it more slowly. So what we see here is the first step, the first network communication that the shark stealer is usually doing, and it's accessing a Binance URL. And if you do some research around this URL, it's basically the BNB testnet API endpoint, which can be used to access the BNB smart chain. Basically, there's smart contracts running on there. This is also what we basically see here if we go into the network communication. So this is the first thing that usually happens. And of course, when we write a config extractor, it's always the why does it do this? What's happening here? This looks legitimate. What's going on here? And then what we can do is we can actually have a look into the decrypted network traffic that's happening here. And we see a post request here, and we see there's a reply. So we can have a look at this. So this part here is the post request that's being sent to this API endpoint from Binance, which is basically RPC call, which is called ether call. And then it has the smart contract address here. And then there's a reply, which is basically more or less only one big hex string / number. And that's it. But then this is used to actually decrypt the EC2 server. So what Shark Stealer is doing here, Shark Stealer is using AES-CFB for decryption. And it has an embedded encryption key in the binary. So this key is necessary to decrypt the information from the blockchain, from the smart contract. So looking at the smart contract or the blockchain alone doesn't really help without the encryption key. But then in the executable itself, we only have the encryption key and the API endpoint, but we don't have all the other information. So we need both things. We need the encryption key from the executable, and we need the return value from the smart contract where the encrypted C2 server is actually contained. So in our case, for the config extractor, this value, this encryption key, is extracted from the executable. And then we also have the smart contract here, which is extracted also from the network traffic as well. And yeah, this information we can use to decrypt the C2 server, and how Stealer is basically doing it. We can take this return value and we can throw it into CyberChef and firstly start just to hex decode it. And then what's important to know is basically this is the initialization vector. So the IV for the encryption is here. The first character is actually just discarded and ignored. Then this is followed by the initialization vector for the decryption, and then this is followed by the C2 server. And all of this we can basically use to just decrypt this response. So we have the IV, which we'll put in here. We have the encrypted C2 server, and then also as I said before, we have the encryption key which is embedded in the executable itself. And this leads us to this C2 server that's actually being used. Yeah, and this is, I think it's a very, very, very interesting strategy, because just looking at the binary itself, we cannot really extract the information what the C2 server is. So we need to look at the whole chain. We need to look at the key. We need to look at the network communication. We need to look at the smart contract. And then if we use the proper decryption routine, we can get the C2 server, which we then will also see here in the network communication. Stealer it attempts a couple of different ports here in the 54,000 range, and then tries to contact the C2 server. Yeah, and that's more or less it. The other interesting thing also, if you want to look a bit more in the big picture in the campaign itself, is we can of course also track a little bit the smart contracts and the blockchain that's being used here. So if we take these smart contracts, we can actually search them in the BNB Smart Chain Explorer, and we can see basically when they're being updated, when they're being modified, and we can see also the contract creator, which is this address. Which gives us insight basically in the whole campaign when this started, and also we are actually seeing it's still ongoing. So there was a new contract being created 39 days ago. So we can basically expect to see this contract here in some of the next samples basically. And yeah, we get some pretty good insights into also when this started. So this was basically first half of this year. And yeah, it's still going on now. And yeah, as I mentioned before, from a detection perspective, I think it's super interesting because this URL, it's been stable for the whole year. This is what they try to access first. If they cannot access this, they basically don't have a C2 server. So, and I don't think a lot of companies would probably use this regularly or legitimately. So I think this is a really great detection opportunity as well, and like actionable threat intelligence. Yeah, and I think that's more or less what I wanted to share about Stealer, how the config works, how the config extractor works, and how our config extractor also looks like if a sample is uploaded here. There's some variables, of course. The network communication needs to happen. It needs to be decrypted in between as well with TLS decryption. But then, all in all, I think it's a really cool help if we see this type of malware as well. And yeah, that's it so far from my side.
Amazing. Thank you, Julian. And really interesting to see how really ether hiding plays out in the wild. And kind of it feels like kind of the threat actors have a catalog of techniques they use at the right time, because I mean, not smells like coincidence to see ether hiding, which was first surfaced, I think 2 years ago, right?
Yeah.
Yeah, and right now we see North Korean threat actors are using this as part of their long tail campaigns. So that's really interesting. So I'm gonna take over to go through some resources before we jump into the Q&A. I would like to quickly point you to the resources, and this is also, I think, a good time to give a quick shout out to the community, because throughout 2025, a lot of the detections and ideas we talked about in these webinars were inspired by great, really public research, blog posts, MITRE, of course, and GitHub repos, and other write-ups. So big thanks to everyone contributing out there. And I think we can move on to the Shark Stealer report is accessible here as well. It's better to highlight this again, and we're gonna share these resources as with the recording. So this was kind of this takes us to the Q&A. I'd like to open it up, and thanks for sticking with us. And actually, there are a couple of questions, Julian, to you. One is actually from the CTI, from the threat intel perspective. I think kind of attribution is always a topic to discuss, but really, does ether hiding, for example, make attribution any easier or harder? I mean, since it relies on, of course, blockchain infrastructure and it's known for anonymity, but are there any signals like there that can help tie activity back to the specific actors or campaigns or some clues? I think you were able to share a screen around the smart contracts around that specific address, but yeah, what would you say about that?
Yeah, I think it's possible to some degree. So these blockchain transactions, they need to be funded somehow. So there's usually like a funding address, and depending on how careful the threat actors are, of course, this could potentially be traced back to like where the money is coming from to fund these addresses and to do these transactions that are required here. I know there's companies specializing in this type of blockchain analysis. And so I think it's potentially possible, yeah.
Yeah, great. And another one, Julian, I think this is also kind of expected by you, but do you expect this technique to stay mostly first of all to stay or following up on that, stay mostly in the Stealer space, or could we start seeing things like loaders or other initial access malware adopt this ether hiding as well?
No, I think it's always difficult to predict.
Yeah, this kind of requires some speculation, but yeah, what
Yeah.
your
So I think it's an interesting technique, but I wouldn't be so sure if it's actually going to stay or if it's going to be popular, because the threat actors are required to use some kind of API endpoint if it's cloud hosted, and relying on this single API endpoint is, of course, as I mentioned before, it's a good detection opportunity. So I don't know how viable it is once this becomes a bit more well known and better detected as well. But yeah, we will have to see.
I think one interesting detail was there, like it is around like 50 pennies to $1 to change the IP in the background, right? The infrastructure. So it makes it resilient for the threat actor, right?
Yeah, it is resilient to a point, but also as it's not that resilient if it's going through one company's API. So then there's still this. I mean, the blockchain might be distributed in the end, but if it's only one company's API endpoint, it's not that resilient or distributed anymore.
Yeah, definitely. All right. We will leave it there. A big thanks again, Julian, to you for the spotlight, and thanks to everyone who joined us today and all year long. As this wraps up 2025, we got a lot planned for 2026. I'm sure you do as well. More intelligence highlights, more insights, and more ways to turn detection into kind of actionable CTI. And our next webinar will be at the end of January 2026. So keep an eye out for the invite. And if you are attending this Sense CTI Summit in the US next month, we will be there. Also, we will have a session in the virtual track. So we'll love to connect. So until then, enjoy the holidays and thanks everyone and see you in 2026.